introduction into what Amazon API Gateway is, right? What it does, how it works, different ways you can run it. Let me move here. So yeah, we're gonna do a brief overview. Like I mentioned, there's different ways it can run. So there's HTTP and REST. Those are similar. We'll talk about the differences about these. I'm going to talk about WebSockets. What are they? How do they work? And a couple of limits to make sure you think about these when considering using API Gateway and designing your systems at some point. So the brief introduction. My name is Andres Moreno. I'm an architect at Tyler Technologies. I'm heavily focused on serverless engineering on AWS. I'm an AWS community builder and a Believe in Serverless community champion. You can find my blog post at andmore.dev, and I'm at andmoredev everywhere: GitHub, Twitter, LinkedIn, or X, LinkedIn, Twitch, YouTube, wherever. I post in other places more than others, but you can follow me anywhere and track those. So brief overview, right? So what is API Gateway? API Gateway is a fully managed service by AWS to create and maintain REST APIs. So REST is a specific way you can design your API. So there's several rules based on how you name your paths and your properties and how you use the verbs and all that, right? So we're not going to go into what REST fully means, but it's just a set of patterns to design your APIs, right? So it's a RESTful API. So it's fully managed, it's serverless. You don't need to worry about the scaling. They take care of that for you. So no need to set up any load balancers or anything like that. That's fully managed by AWS, and they take care of that so you don't have to worry about it, and you can focus on your business logic and where you can provide more value. And they have tooling around it to help you publish, maintain, monitor, secure, and operate these APIs at any scale, right? So a lot of integrations within the AWS ecosystem, and just helps you iterate a little bit better and maintain it better. So like I mentioned, there's several options on how you run API Gateway. So the first two are what they call HTTP API and REST API. This is the name API or AWS gave to these. It's rather confusing when you're Googling, hey, how do I do something in HTTP API? Because that's kind of like everything. But that's what they named them. These HTTP and REST are both for request response model. Basically, what this means is I'm going to do a request to the API, and I'm going to expect a response. And it's going to happen immediately. Whether the process is triggered asynchronously or not, that doesn't matter. You're going to get a response, right? So it's kind of very synchronous in that manner. With HTTP, you have a more limited feature set. So the plus on that is that it's faster and cheaper. So things to consider when running HTTP, right? And when you use REST API, an API gateway, it has a lot more features, but it does have more latency and cost to it. So we'll go into more detail on what those differences are. And then there's WebSockets. So WebSockets are used to give bidirectional communication between a front end and a back end, right? Your client and your server. So imagine you're in a website and you have a process that's going to take 2 minutes. You don't want to wait with a spinner for 2 minutes, right? So what happens in those situations, what we typically do is we send a request and a response immediately saying, we're processing this. And then you can use WebSockets to send messages back to the user interface to keep it updated. So that's kind of the main use case for WebSockets. And we'll go a little bit deeper into how that looks technically. So let's go deeper into HTTP and REST, right? How does these flow in your account, in your system? So you typically start with a client. This could be a server, This is called host, but it can be a browser, right? Chrome, you're running a website, or a mobile phone, right? These these devices or servers are going to make a request. So they go through the internet and make a request to you. Where that goes in is API gateway. In this scenario, let's say we're querying for a list of users using our REST API. So we're doing a get and slash users, that's our endpoint. It's going to go hit API gateway. What we can do from there, right? We can tell API gateway, once someone hits this endpoint, take it somewhere else, right? In this situation, we can tell it to go directly to a database. In this case, DynamoDB. That's a serverless database offering from AWS. You can tell it to go to a step function. That's kind of a workflow state machine runner, right? Where you can define multiple tasks to run in sequence. So we can tell it to go directly to these. We call these direct integrations. So with a little bit of configuration in the API gateway, or sometimes a lot of configuration, there's trade-offs if you choose this route. You can go directly to a specific service without having to run any type of compute like Lambda. But the typical tech stack you see is it's going to go from API gateway to Lambda, right? That's simpler. You don't have to go into that confusing configuration, which is called VTL, Velocity Templating Language. And I see Benoit laughing. It's like, yeah, we don't have that in AppSync. But it's he'll go over that. But it's a very complicated way to manipulate and just transform things. It can get pretty complex. So people might choose to just run a Lambda function, which you can then connect to the same DynamoDB or step function, right? So there's two routes you can take as far as connecting services here. And once you do your processing, you obviously send a response, usually 200, 201, 202, depending on the type of endpoint you're hitting. So that's kind of your typical flow with an HTTP and REST API from API Gateway. But what are the differences, right? There's these two offerings within the same service. And I'm going to go through, I have here in the slides, just for reference, I have the full list. I'm not going to go through the full list because there's several differences between these, and it would take me an hour and a half to go through all of those. So I'll just highlight a few. So endpoint types, right? With REST, you can have edge optimized. This means they can run faster, closer to me, where I'm running it, where I'm calling it from. You don't have that with HTTP APIs. But again, HTTP APIs are already faster. So you would have to do your assessment into if it's actually a sacrifice or not, right? And then one could be more of a regulatory constraint, but you can't run private APIs, and that's just the way you can run API gateway constraint to your account or your VPC, so it doesn't go out into the world. As far as security, the one I hear about the most is AWS WAF. So not having that support for HTTP API really prevents people from using it. What is AWS WAF? It's the web application firewall. This basically gives you out of the box DDoS protection. So it really simplifies that cancellation of an IP or something that you don't want bringing down your system, right? So you don't get that with HTTP API. Is authorization, a lot of similarities. So one that HTTP API doesn't have is resource policies, but the one I like that it has is the JSON Web Token support. So you basically get this only in REST API if you're using Cognito. But if you're using HTTP API, you can be running your authorization in Okta or Auth0, wherever, and you can configure it for it to automatically validate that JSON Web Token without you having to run what they call Lambda Authorizer, which is extra piece of code and config that you would need to run. So that's a big win for HTTP API there. API management. thankfully both accept custom domains. These are to make your endpoints and your base URLs prettier. But these other three, I like to kind of bundle up together: API keys, per client rate limiting, and per client usage throttling. These come as a feature called usage plans from API Gateway, which allow you to protect your API from kind of the noisy neighbor kind of situation. So I can give a client one API key and they can do 10 requests per second. This other client pays me more. They can do 60 requests per second. And you can have that level of control with these things. So big difference between REST API and HTTP API there. And again, all of these have links so you can dig deeper. Once these slides will be provided, so you can dig deeper into all of these, what they mean, so you can make the right decisions for your business. As far as development, you can see there's a big list. So big ones, test invocations. I use those mostly for like troubleshooting an error or something. So you can go into the console and trigger your endpoint, kind of like if you would from Postman, but you kind of bypass the security, so it makes it a little bit easier. You don't have that with HTTP API. Canary releases, right? If you want to be able to slowly deploy your API to a subset of users and not the whole thing all at once, you can't do that with HTTP API. Caching, again, that's kind of a performance implication. You do have caching in REST APIs, but again, HTTP APIs are already faster, so the trade-off might not be as great as you think, but that you would need to analyze that. And maybe it's more of a cost perspective and not performance where you're analyzing this. And monitoring, I thought it was the last one, but it's not. So we got monitoring. Two big ones for me that I use a lot. I work in a very regulated space, so having execution log and the X-ray tracing, I get all that built in with REST APIs. You don't get those with HTTP API. So again, for you to analyze, if HTTP APIs, what I get are for simpler, faster APIs, right? So you don't really need this because it's already kind of slimmed down. And last but not least, we got the integrations. So it does list AWS services as both having them, but this is one of the preventers for me on using HTTP APIs is that so hard to pronounce, HTTP APIs only support around 10 to 15 service integrations. The ones I mentioned, you can go directly to them. REST API support over 100, right? So I use DynamoDB a lot, and for me to be able to remove the compute, right, the lambda in the middle, is very beneficial. And HTTP API does not support DynamoDB direct integration. So things to analyze. Going through the list, mock integrations. So if you follow me, you know I'm a big advocate for API first development. So define your contracts first, your open API and all that, then start development. So I make use of mock integrations, which allows me to create basically like a fake API. But this gives me the kind of the schema, the structure that's going to be working for our user interface and that the backend needs to respond with. So you can achieve this with mock integrations so that you can serve these up to a front end and be able to work out of the same contract. You don't get that with HTTP APIs. There's obviously different ways you can do this with other tools, but natively with AWS, this wouldn't work with HTTP APIs. So again, a lot of points there and differences that you would need to analyze. But I will jump now into the WebSockets portion, right? So this is what I mentioned is the bidirectional communication between a client and a server. So how does this look? So similar diagram, right? We're still calling in from the internet into an AWS account with API Gateway. So the first thing you do is connect, right? There's an endpoint, a specific endpoint that's made available when using API Gateway as a WebSocket client. So you call this endpoint slash connect. Um, through API Gateway, it will provide you with a connection ID that you can use um, here, right? So in this scenario, I'm using a Lambda function to then store that connection and keep it for me because I later want to send messages to that connection, right? So as long as that connection is active, I can keep communicating back. So it's like having an open channel with them. Uh, there's a bit more involvement, and you'll see from what Benoit presents, the pub sub with AppSync is much easier than what you have to do with API Gateway, since we have to maintain the connections here. So once we have that connection saved, we know we have these 5 connections that want to listen to the specific thing. So what we do now to broadcast the message and send the message back out to our clients is we start now from the other end, and we're going to get the connections that we have saved off, right? So there's a little bit of data modeling to see how you want to broadcast messages to your clients. But in this scenario, let's say we just want to broadcast all. So we get all the connections we have saved using any type of compute, right? You can use Lambda, step functions, or anything. And then we send a publish message, right? An API call to API gateway that's called publish message with the information we want to send out to those connections. In this situation, that publish message needs to be done once per connection. So you got to loop basically through each connection ID that you have and publish that message, boom, 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 boom. And then we'll send that message out and it'll get received by the subscribers. In this case, we only have 2 out of the 3 that could be subscribed. So server and device get their messages back and we can update the UI with like a status message or something like that. So it's a way for me to provide a better user experience when we have long running processes. And last but not least, I mean, you have to disconnect, right? So if you're working like in an Angular application, you have the ng destroy message or event on the page lifecycle. So you can unsubscribe at that point. It'll trigger the disconnect. We go process that, delete that connection. So we're not broadcasting to no one. So you have to do the cleanup yourself as well. And as far as limits, there's 2 I want to call out. Obviously, you would need to look at, there's the service and quotas pages for any other limits. But the 2 I see called out the most are the 30-second integration timeout. What does this mean? So API gateway, if you trigger, let's say a Lambda function, that's going to take 2 minutes to run and process. If you're waiting for that, API gateway is going to send a timeout at 30 seconds. That's the max timeout. As of last week, this is now configurable. It used to be a hard quota, but it is adjustable, but they say it sacrificed throttling limits. So I still don't know the relationship between how much it's affected. It's so new. I haven't tried it yet. But something to consider if you have a long running process, this might affect you. But again, there's design patterns you can use to, hey, let's run it async and trigger WebSocket events instead of waiting for 5 minutes for something to process. So things to think about. Another one I've hit several times in my career is the 10 megabyte payload size limit. This one is a hard limit. 10 megabytes is a lot of data you can process, but if you're working with like images or PDFs or stuff, usually the simple route is let me go through API gateway, send the image as a base 64 encoded file and save it into S3. If images are huge nowadays, so they could easily go past the 10 megabyte limit. So just something to keep in mind that might change your design as far as how you handle those things that have a bigger payload. So that's about it as far as me introducing API Gateway. So we went through what it is, the different ways you can run it, how these different ways work, and how you can leverage them. As I mentioned, I'm a Believe in Serverless community champion. We're doing this collaboration with Gun.io. This is lovely. So I put a QR code there directly to our Discord. And this should have a link. Yeah, so there's a link in the Meet Us that goes to believein serverless.com where you can get more information on us. So thank you. If you want to follow me on LinkedIn and Twitter, as I mentioned, and more dev, and there's links here in the slides.
Excellent. That was great. Thank you.
All right, let me set up my. Now that Andres just showed you what is API Gateway and the REST and HTTP offerings, I'm going to try to show you what is AppSync. AppSync is the GraphQL offering by AWS. But first of all, I try to introduce myself as well. So I am a serverless developer and engineer at Serverless Guru. I've been there for 3 years now, and I've been involved in the serverless community since maybe 2018 approximately, where I started to get interested into this amazing technology. I've been a AWS community builder since 2021, and I'm also a maintainer of the Service Framework plugin for AWS AppSync. That's actually how I got involved into AppSync about 4 to 5 years ago. I am also the creator of GraphBoard, which is an application to help developers work with AppSync. And you can find me on X or Twitter on the handle of the screen. And you can also find my GitHub and web blog, where you can read a lot of things about Serverless and AppSync as well. So, okay, as I was saying, I will try to introduce you to AppSync, which is the GraphQL service from AWS. But before I start to get into this, I will give a quick introduction to what is GraphQL for those who might not know it already, and maybe compare it to REST, like traditional REST APIs, and see how they compare and why GraphQL might be trying to solve some of the issues that REST has. I will finish then by explaining what is AWS AppSync and get into more details about it. So what is GraphQL? GraphQL was introduced by Facebook about in 2012. It was first used internally for their own application, but they made it public as an open standard in 2015. And GraphQL essentially is a query language for APIs. It allows you to explore your data through interconnected nodes and edges by the use of a simple API. One way to understand what GraphQL tries to solve and the issue it tries to solve is to compare it with REST. So in a traditional REST API, let's say that you have an application that needs to bring different types of data. So your client needs to show information about a user. Let's say they want to show information about the user profile, addresses, etc. Anything. In a standard traditional REST API, the way you would usually do this is, okay, you're going to have to run maybe 3 different requests. The first one is going to call the /users API, which is going to give you the information about the user. Then to get the information or the URL of the profile picture, maybe you're going to have to call a second API, /images. And again, to get the addresses of that same user, you're going to call a third API. Sometimes you will even have to call these APIs sequentially, because maybe you're going to get an ID. So maybe the profile address, sorry, the profile picture ID from the user is returned by the /users API call. So all of this makes your application a bit slower because it has to do several round trips with the backend, wait before one response is returned, before emitting the next sequence of requests, which makes everything slower. That is a problem that in the GraphQL world we call underfetching, because one API does not give you all the information that you need. Now, a second problem, as opposed to underfetching, is overfetching. And overfetching happens when you're going to call the /users API, is going to give you the ID of the user, the name of the user, say the email of the user, but it also gives you, I don't know, a biography, which is 3-5 paragraphs long. Maybe you don't need that, and your client doesn't care about it. So what it's going to do is going to discard it. However, that information still has to travel over the wire, which makes your payload larger. And you can hit limits, like Andres just showed you, or just by being larger, it's taking more time, of course, and consuming bandwidth. So that second overfetching problem is just this. GraphQL tries to solve those problems because it gives you one single endpoint, one single API that allows the client to fetch everything they need, but only what they need in one single query. In a way, the backend acts as the glue for your data, because the backend is going to get all the information it needs. It could be from different data sources, different databases, different sources, get everything it needs, put it all together, discard anything that you don't need, that the client did not request, and then it's going to return everything at once back to the client. So that reduces the payload, that reduces the information the amount of information that is returned, and also it avoids having more than one round trip to the backend. So that's the way that GraphQL tries to solve the overfetching and underfetching, because everything happens in the backend as opposed to the front end. So to allow that, GraphQL has 3 types of operations that we can use. So the first one is queries. And a query, you can consider it like a get operation in the REST world, because it allows you to get information from the data sources, from the backend. It's a read operation in the end. The second type of operation is mutation. And a mutation is like a post, put or delete in the REST world. It allows you to create, modify, or delete data. It manipulates, it mutates the data in the backend. And finally, there's a third type of operation that is supported by GraphQL called subscriptions. A subscription is a real-time pub/sub way to connect with the backend. So Andres just showed you as well what are WebSockets, and subscriptions is the equivalent of that in the GraphQL world. So if we take an example, if we have a chat application, if you have like, I don't know, queries, will help you to get the chat information, the groups, the conversations. Mutations would be for creating messages, sending messages, creating groups, etc. And subscriptions would allow you to get real-time information, like real-time notifications of new messages that are sent by any other user. So to do that, one thing that GraphQL also shines at is that it uses a schema definition language. GraphQL is fully typed, so it means that everything, both the input and the output of request and the queries or mutations that you send are validated, and they must match what you define in your schema definition. In the schema, you will define all the queries you have, all the mutations and subscriptions as well. So it will tell the API what you can do and what the user can get from the backend or what it can create in the backend, and define exactly what are the types and operation that can be done. Every time that a client sends a request, the input and the information that is requested by the client will be validated. So that means that the client will not be able to fetch data that it's not allowed to because it's not defined in the schema. And it won't also allow the client to send information. In the case of a mutation, you will not be able to send data that it's not expecting. And all the validation happens at runtime. So that's what, in a nutshell, GraphQL is. So now let's get into the specifics of AWS AppSync. AWS AppSync is the fully managed GraphQL offering by AWS. It's fully managed, meaning that you don't have to worry about managing servers, patching them, maintaining them, nothing like that. You will have to only pay for the requests that you make. You will not pay for idle, meaning that if no client sends any requests, you have 0 requests in a month, you won't pay anything. It is also very highly scalable, meaning that you can receive thousands of requests per second, and AppSync will automatically scale. You will not have to worry about it. It can also scale even to millions of subscriptions. So if you have a chat app with millions of users in it, something like, I don't know, Discord, there's no problem to that. AWS will manage it, and you don't have to worry. So the only thing you have to do, in a way, with AWS AppSync is that you will provide your schema that we just described, your data source, and your resolvers. And I will come to details about those two in just a minute. You deploy those to AWS using your favorite infrastructure as code, and everything else is fully managed by AWS. So talking about data sources, what are data sources? AppSync, just like GraphQL, they both use data sources to tell the schema, to tell the API where to get the data from, or where the data is persisted. And AppSync supports 7 types of data sources. The first one is DynamoDB, which is the NoSQL offering database by AWS. You can also use an AWS Lambda function if you want, which gives you a lot of flexibility because you can use it to write your resolvers in any language you want, get data sources, information or data from data sources that are not supported by AWS or by AppSync by default, and gives you a lot of flexibility around business logic, like you can do more stuff if you want. There's also OpenSearch, which is also known as Elasticsearch, which is used for a fast search capabilities. So your API can do searches in your backend. RDS, which is for if you want to use relational databases like MySQL or Postgres. Then there's two special data sources. The first one is HTTP, which essentially allows you to connect your GraphQL API to an HTTP API, to a legacy, maybe REST API. That can be useful for 2 use cases or more, but there are 2 use cases where it's very useful. So the first one would be maybe to connect to a third party, which provides you with an HTTP API. So you can consume the HTTP API directly from GraphQL, and GraphQL will act as a frontier before the HTTP API. And the second one is, you can imagine that if you have a legacy API, you have a legacy HTTP or REST API, and you are migrating to GraphQL, well, you still can use that legacy HTTP API, and you just put GraphQL or AppSync in front of it. And then slowly you can start migrating it from like HTTP legacy to the new GraphQL API. And the last but not least is the non-resource or non-data source. A non-data source is essentially a way to say the GraphQL, okay, well, I don't have any data anywhere. I don't need to fetch data from any data source or from any database. Maybe I just want to manipulate data. I want to process it or something from the input payload, and then just return it to the front end. That's sometimes useful for subscriptions in some complex cases, but most of the time you will use a proper data source. And I forgot one actually, which is EventBridge. It's technically not a data source. I would not call it a data source, but it's a way for you to write and put a message into an EventBridge bus from GraphQL. So most of the time you would use that as a way to tell your system that something happened. So it could be, okay, you create a message in a chat application, you send a message, and then you want to broadcast something somewhere in the backend to say, okay, a message was created, and then you want to do something asynchronously with it. So that's how you would use and why you would use the EventBridge data source. Of course, you are allowed to mix and match all those data sources. It doesn't have to be just one or limited to one. So in the case that you want, I don't know, you have a query which fetches data in DynamoDB. It's just a get. You have the ID of that message, you want to get it, or the group chat, whatever, you can get it. But let's say you want to do a search in the history of the chat. Then maybe you're going to use OpenServe for that. And that's going to be a different query, a search query, which is going to be connected to the OpenSearch data source. And then it means that each query, each mutation can do whatever you want and use the best data source for each use case. So actually, you can see this here. You can see that in the backend, there's a one query is using DynamoDB. There's another one using HTTP and another one using Lambda in this case. Okay, so what else? Resolvers. Resolvers in GraphQL and AppSync are like functions that you can attach to a specific field. So when you query your GraphQL API, you are allowed to get, okay, all the information that you need. And each field that is returned by the API, you are allowed to attach it to a resolver. Each time that a client requests that resolver, that field, the resolver that you attach to that field will be invoked. And a resolver is no more than a function. It's a function that is attached to a data source. And that function has two roles. The first one is to generate a request or a query to the data source. So for example, if it's DynamoDB, it will generate the query for PK and SK of that DynamoDB table. Then it's being sent to the data source, and the data source, based on that, is going to return that information. So it's going to return the data that you requested. And then the second thing that the resolver will do is that it will get all that information, and it will process it and return it back to the requester, so to the client. So that's essentially what it is. So a resolver essentially acts as the glue between the schema, the API, and the data source, the backend of your databases. There are actually two ways of writing resolvers in AWS AppSync. There's one historical way, which is the VTL template that Andres talked about a bit, which was a bit of a very hard language to learn. But since, I don't know, a year and a half now, I think, you can and you're allowed to write resolvers in JavaScript, which also in turn allows you to write them in TypeScript if you want. So that only just improved a lot the developer experience, in my opinion, which is great. Of course, you still can run and create resolvers in Lambda. So if you want more complex things and more complex business logic, or you want to write your resolvers in a different language like Rust or Python, then you can do that as well. Okay, so now when you talk about an API, you will most likely want to protect it and also authorize and identify your users. AppSync supports 5 types of identification or authentication method. Amazon Cognito for the AWS offering of a user directory. You can also use IAM if you have, or if you come from a different authorizer, like, I don't know, Okta or Auth0, you can do that through OpenID Connect. For my kind of public APIs, you can also use API keys. And for more complex scenarios where you want to have more control about what your authentication looks like and what it does, or maybe connect to something that is not supported natively, you can also use AWS Lambda. Now, back to subscriptions. I think we've described a bit what subscriptions are. So essentially, it's a pub-sub connectivity, real-time notification that you can establish with the backend. And the way you will use this most often is that, okay, so you have some clients that are interested into some changes that happen in the backend or happen due to the actions that other users take. So again, in the case of the example of the chat application, if I am in the chat group, I send messages, but I also want to receive messages in real time that other users send. I also want to receive notifications maybe on my phone. So subscriptions allow you to do that. So the way it works in AppSync is that a subscriptions, when it's defined in your schema, you would attach it to a mutation. You would say, okay, whenever a client sends a mutation of this kind, I want to be informed about it. And I want to receive the payload that was returned by that mutation. So in the case of sending a message in a chat application, that payload might be the message itself and its ID and who sent it, whatever. So everyone that is subscribed to that mutation will receive that in real time. And this is fully managed by AWS. You don't have to worry about anything. You don't have to build anything. The only thing to do in AppSync, in your schema, you will use what is called a directive. So we'll put some annotation next to the subscription saying, okay, that subscription is interested by all the changes happening in that other mutation. And that's all you have to do. Everything else is fully managed and fully scalable. AWS AppSync is able to scale to millions of subscribers simultaneously, and you don't have to worry. All right, so Andres talked about cache as well. AppSync, of course, also supports caching. It's allowed to cache at 2 levels. The first one is the full request. So I don't know if you get information about a user, addresses, description, whatever. If many users ask for the same user many times, then the first request is going to cache it, and all the other requests are going to get that information from the cache. That allows you to protect a bit your databases and your backend, because it avoids hitting it many times. It's also very, very fast because the cache is in memory at the AppSync level directly. So you don't have to wait for the database to respond or anything. And the second kind is per resolver. So I mentioned that resolvers are like functions which are attached to a field. So imagine that you have a field addresses in a user, and you want to put cache at that level. So only the addresses of that user, because they don't change very often, are going to be cached. All the rest of the information, maybe their username or whatever, won't be cached. There are two things to consider when doing cache in AppSync. The first one is the caching key, which defines how the data is actually cached. So depending on the request that is made by the client, you will define your key. And if anything changes in the request, let's say the user ID, if the user ID is the cache key, if you request a different user, then you will get a different cache key. So the cache will not be shared between two users. And the other thing to consider as well is the time to live. So there's a limit of, I think it's a hard limit of 1 hour in AppSync, but you can decide it to be 5 minutes or 1 minute or 30 seconds, whatever you want. After the time to live is expired, the cache will be cleared, and a new request will force the data to be fetched again from the data source, and it will be cached again. So how to work with AWS AppSync? I collected a few tools and utilities you can use to work with AWS AppSync. Just to start with, the infrastructure as code for deployment. You can use pretty much whatever you want. There's the Amplify CLI, which is a framework by AWS. You can use SAM as well, or the serverless application model. You can use the CDK, serverless framework, plain CloudFormation if you want, and many others, like, I don't know, Pulumi, whatever. I think the acceptance of AWS AppSync is quite large, so it's supported by many libraries. And also client side, you might want to look at the Amplify.js library, which is also by AWS. It allows you, from the front-end perspective, to connect to your AppSync GraphQL API. But if you want, you can also use Apollo client, which is also a client for the front-end for GraphQL, but it's fully compatible with AppSync. I also noted a GraphQL code generator. That's something useful I used a lot. It helps you generate TypeScript types or whatever language you're using, using your GraphQL schema. So based on the schema, you can generate types and models for your front-end application. And the Amplify CLI also offers this option, and many more, actually. So yeah, I think that's it. Yeah, thank you. So if you have